again, and I will keep this in here. Oh, and that's contract with an R. But anyway, and actually I'm going to put this all after what we've already built. There's no reason to put it in the middle there, confusingly. We'll leave that at the end. Okay, and then contract, I'm going to call it a holiday, holiday savings wallet. And just to nail down what we're trying to do here, and since I just started the recording as well, the suggestion from Seiron is to make a savings wallet with a timer, where you can only withdraw the money right before the holidays or Christmas. So we'll just say Christmas just to be arbitrary. Now I don't know about putting an annual date in there, so we're just going to hard code it for next Christmas. So we'll just do Christmas savings wallet. And I don't know how useful this would really be. You know, do you really want to lock up money to where you can't ever take it out until a certain date? But it, you know, maybe some people would want that, and it should be pretty easy to write. And we can also show off how we can sort of, you know, inherit the wallet functionality, and sort of overwrite what we want to overwrite. So that's a great suggestion, Seiron. So Christmas savings wallet. The main difference here is that we want to prevent withdrawals before a certain date. Let's go ahead and define that date right now. Uint, let's see, what should we call it? Withdraw date, withdraw enable date, I guess. Withdraw enable date. Timestamp, I guess, would be a little clearer. And we're just going to hard code that in. I'm going to go to unixtimestamp.com and enter a date. So we're going to say Christmas of this year, and that is 12/25. And yes, 0. But if this is a Christmas savings wallet, we don't want the money to come, you know, to release right on Christmas. You want to do it like a month before, right? So you can buy stuff. So we'll make it 1 month before Christmas is the timestamp we'll get. Yep. So that's our timestamp. This is 1 month before Christmas, and that's when the withdrawal will be enabled. Okay, so there's our date, and we'll make this public. Okay, and then let's see. So now what we want to do, I think the only thing we'll have to do is just overwrite the withdraw function. Oh, nice, I can collapse that. That's great. I love it when you can do that. So here's our wallet functionality. We just need to overwrite the withdraw function. And it's external. And then Yep, that's absolutely right. And in fact, considering that this could be used for holiday savings and for you know, locking funds for a miner, if we were sort of dedicated to building this primitive, we would want to work on the name. So I don't want to really focus on it too much, but just to illustrate a little bit, we might call it a, well, I suppose it's really just a time-locked wallet. That's exactly what this is, and I guess that's what we'll call it. So, yeah, that's a great point, David, and it allowed us to really get at the core of what we're doing here. So great comment. Thank you for that. Okay, so let's see. Withdrawing, we're overriding with the withdraw function. We still want only the owner. We still want that that modifier there. And then, but additionally now, we want to require that now is greater, or other words after, that our withdraw enable timestamp. And then I think we can just go ahead and actually call withdraw from our wallet. Let me just look up real quick. Solidity call inherited function. Well, let's just see if this gets us what we want. Owned is oh, here we go. I guess I missed that. Notice how in the code we called mortal contract.killowner. Where is that? Ah, here we go. So it looks like we just, I guess it's pretty clear. I mean, I almost could have guessed it. I gotta express some appreciation in for Solidity. If it really is that simple, that's quite easy. So okay, then we just say wallet dot withdraw amount, like that. Now there will be an issue here, and that is that our wallet here has an external modifier, which means that internal functions can't call, or sorry, it can't be called from within the same contract. And I believe that even though we're inheriting, so it's sort of, it looks like it's from a different contract block, I think this will still block us. So I'm going to change this withdraw function to a public, so that internal calls are not excluded. And there's no reason to change that to public, because we're never going to be sending ether from the contract to itself, I think. I think that's like literally it. I mean, when we call wallet.withdraw, it's going to go up to this code and do these checks. So actually, we could even take this modifier out, because that will be run when we forward the request up to this one. So I'm going to take that out there. So this is pretty clear what's happening. Again, thank you, Solidity, for being easily readable. This TimeLockWallet has a withdraw function, and literally all it does is it just has this additional require here, and then sends the request to the base functionality withdraw. And withdraw will transfer to the owner, so we don't need to worry about where it's going to go. Okay, let's see if it compiles here. Whoa. Overriding function visibility differs. So I guess we have to have the same visibility on these. I did not know that. But that's fine. Okay, that compiled. That's good. Let's test out our TimeLockWallet. That's a great suggestion, guys. You know, I go for all the complex stuff, and it's great to hear what the people who are new to this stuff want to go and try to build, because it just we can build them quite quickly in some cases. Okay, TimeLockWallet. Deploy does not implement all functions and thus cannot be created. Does not implement all functions. Okay, well, I guess that just means I need to. The only function that's not implemented is the fallback. Well, also the constructor. Well, okay, let's start with the constructor, because I definitely need that. Constructor address. And then we're just gonna, again, pass that up, and we'll leave it empty otherwise. We could pass in here the withdraw enable timestamp and not have it hard coded, but I'm not going to worry about that just right now. Okay, let's compile and see if that fixes it. First of all, TimeLockWallet deploy. That worked. Okay. We didn't give it an owner, which is interesting, and it still went. I bet the owner is 0. Yeah, so we'll have to redeploy that. So TimeLockWallet owner is going to be, select our first guy here. Copy, put it in, and deploy. Okay, now we have this TimeLockWallet. This is cool, guys. This is great how quick this is going. And we can see the owner is set as it should be. Withdraw enable timestamp is set to our constant there. Oh, of course, we're not going to be able to test this until Christmas, so I guess I better I guess I better change this to something more reasonable. Okay, so let's clear this, and I'm going to now go to Unix timestamp. I'm going to close some stuff first here. Close all of this and this. Okay, so when we're testing this, we want to test two things, essentially. We want to test that we can't withdraw the money before our time and that we can withdraw it after the time. So, so instead of this number, I don't want to wait months to test it, so we're going to redeploy with a different timestamp. I'm going to take the current timestamp, whoops, god dang, and go to the calculator, paste it in, and I'm just going to add, let's see, how many seconds. I guess I'll do 3 minutes. That'll give us a little bit of time. So, and I better hurry because this is from the current. So 3 minutes is what? That's 180 seconds. 180 equals, okay. Put that in there, and that's very quickly go, compile, run, get our address here as the, and change to TimeLockWallet, paste the owner to deploy. Okay, now let's see the timestamp. Let's make sure that this is less than what this will be if I refresh. Okay, so it is 63744 right now and 63847. So we are not yet there. So now if I try to withdraw, it should fail. Of course, first I need to put money in. Ooh, I need to hurry. Okay, let's put 1 ether in. Click the fallback. We got 1 ether in there. Let's try to take 1 ether out. Draw. Okay, did not work. So that's good. That's a good sign. So now we just need to wait until our timestamp passes this number and try again, which might be a couple minutes now. Let's see where we're at. We are at 3778. We need to wait till 3847. So just about another minute here. We'll try it again. In the meantime, I'm going to add in, I'm not going to redeploy, but while we're waiting here, I'm just going to add in a message here. I should have done that at the beginning. Let's see. I'm tempted to do something cheeky like, not yet. Okay, let's see if we're there yet. 847, 821, just a few more seconds left before we can get at that sweet 1 ether, 1 fake ether in this this contract here. We there yet? Probably close. 45, 47. Okay, so we're at 3848, which is greater than 3847. So now, changing nothing more than the time that we called this, should be able to once again hit 1 and withdraw. Hey, there we go. That's pretty cool, guys. So another thing we can test while we're here, let's put 1 ether in it again, because we just took everything out. And now let's change our user, right? Because we want to see if our wallet functionality is still working. We want to make sure that still it's true that nobody else can withdraw. So let's go to a different user, try to withdraw. Now we're still past this time, so the time lock shouldn't prevent us. And let's just try to withdraw this. And we have an error. Oh, we have an error in encoding arguments. Oh, that's because I tried to put in a decimal. Right, I was putting out an ETH amount. I should be putting in a way amount, so I'm just going to put 1 there and try to withdraw. Okay, we have an error. That's great. let's just debug this to see how that played out, and then we'll end the stream here. So here's our withdrawal in our TimeLockWallet. I don't know why it always jumps to the top like that, but anyway, so here's our first require with our time lock, and this should pass, and indeed it does. And then we go into the wallet functionality and require that the message.sender equals owner, and we stop there. So that's cool. We have our wallet functionality. We didn't need to change one bit. Well, we did need to make it public here, so there's a minor change we did. But then we were able to add this time lock functionality right on top. So very cool. Great suggestion, guys. A great job to Seirun first for just suggesting it, and then also to David for pointing out that we're really working on something quite general. So I think I'll end it there. But a great session, and yeah, I'll see you guys tomorrow. I guess a quick talk on what we'll do tomorrow. And I'll be honest, I'm winging things a little bit this time since we're doing several different projects here. But well, here's what we have to work with. We have a TimeLockWallet, we have a billable wallet, we have a regular wallet, and then we might have a multi-owner wallet if I can find the time to work on that. This is something that, again, if anybody wants any extra homework or coursework, and I want to directly reach out to people in a moment for that, but this would be something for anyone to work on. And then what else? Didn't we build something else? Wasn't there something else we threw together? Oh yeah, we tried to build the forwarder. But so we got a lot of stuff here that we can work with. So tomorrow, it's Tuesday, and so on Tuesdays we try to focus on interfaces. So we'll probably, well, one thing we can look at is the fact that all of these all these contracts here, if we go back here and do our drop down menu here, all of these have a wallet functionality. So we could build an interface that maybe accesses or interacts with, well, forget about the factory for now, but this billable wallet, the TimeLockWallet, and this wallet, we might be able to build an interface that can actually interact with all three of those. You might be able to click on a create button and then there'd be a drop down for which one you actually want to create. And then because they all have this shared withdraw and deposit functionality, we could build that interface to be able to allow the user to do that with any of these. I mean, that should be pretty possible. So that's what we'll explore on Tuesday, is building an interface that actually interacts with multiple contracts. We'll probably also maybe change this into just like a wallet factory, maybe, and then have different, oh, see, I should have changed the name here. This should be a different name. This is new. What do we have it making? We have it making a billable wallet. But and then we can maybe add other functions here, right? Function new new time lock wallet, like so. And then of course we could just do a new function new wallet up here. So I suppose we'll probably do that too. We'll make that change in the beginning of Tuesday's seminar, or I'll either make the change privately and show you what I've done, or just very quickly do it on the seminar. And then we will start building an interface that can interact with the factory and create these three different wallets here and interact with them. And we'll really play a lot with how, I suppose, how one interface can interact with several different contracts. Okay, I've talked enough, guys. Thanks for sticking around, and I'll see you tomorrow.